The Moon is Earth's only natural satellite at a distance of about 240,000 miles from Earth. It was the first place beyond Earth that humans tried to reach as the space age began in the late 1950s. In this video, we will discuss that what will happen if you shoot a gun on the Moon. Will the bullet go into orbit around the Moon, or whether it will completely escape the Moon's gravity? As we know, fires can't burn in the oxygen-free vacuum of space, but guns can shoot. Modern ammunition contains its own oxidizer, thus the firing of a bullet is possible wherever you are in the universe. Now, we know that the bullet has the same initial velocity on the Moon as it does on the Earth. That is, it exits the gun at the same speed, but as soon as it leaves the gun, it is a different story. First, the Moon bullet doesn't have to contend with air resistance. The atmosphere on the Moon is what we consider to be a very good vacuum on Earth. In fact, the density of the atmosphere at the Moon's surface is comparable to the density of the outermost fringes of the Earth's atmosphere, where the International Space Station orbits. With so little friction, the bullet on the Moon can maintain its speed longer than the bullet on Earth. And secondly, the Moon's surface gravity is about 1/6 as powerful as Earth's. If we only consider the difference in gravity, the bullet on the Moon will go 6 times farther than it will on Earth. Once you take no air resistance into account, the Moon bullet has an even bigger advantage. You might ask, if the bullet were fired straight up, could it actually escape the Moon's gravitational pull and fly off to space? To answer this, we have to compare the Moon's escape velocity to the bullet's initial velocity. The Moon's escape velocity is about 2.38 kilometers per second, but a bullet typically travels at only about 1 kilometer per second. So even in this case, what goes up must come down. Now we know that the bullet cannot escape the Moon's gravity, but can it go into a lunar orbit? Theoretical calculations show that for a bullet to go into an orbit around the Moon, it will require a minimum velocity of 1.6 kilometers per second. A 50 caliber armor penetrating round reaches 1.2 kilometers per second muzzle velocity. So even a very powerful round such as this one moves a bit too slowly. It is conceivable that an enhanced 50 caliber round with an extra load of powder and possibly shot from a specially prepared rifle could reach the 1.7 kilometers per second speed needed. In that case, if fired at the horizon, it would do a circular orbit, would go round the Moon and hit the shooter in the back 1 hour and 54 minutes later, provided it doesn't hit a mountain or something en route, and provided the orbit is along the equator. If you are not shooting along the equator, the bullet will still do an orbit, but its motion relative to the surface of the Moon will be a spiral, and it will not return to the starting point as the Moon spins underneath it. The circular orbit requires the smallest muzzle velocity to complete the loop. Any other orbit would require a greater muzzle velocity from the rifle. The more elongated the orbit, the higher the velocity needed. Now you know what will happen if you shoot a gun on the Moon. That's all for today's video. Like and subscribe to the channel, and see you in the next one.